As we continue through Chapter 4, we are going to look at calculating statistics related to quantitative data. One of those statistics we calculate is the center of the distribution. Now, the center of the distribution is the number simply in the middle of the distribution. It's very easy to find when the distribution is unimodal, meaning one hump, and either symmetric or uniform. It becomes much more difficult to find the center of the distribution when it's skewed, bimodal, or multimodal. Now, for the center of the distribution, there's two different measurements we can calculate. The first measurement is the median, which you've probably calculated in the past. It's simply the data value in the middle of the set when the values are in order from least to greatest. That's your key piece. Take your data, put it in order from least to greatest, and then simply count from both sides until you find the data value in the center. And if there is two, hopefully you remember from when you learned this in the past, you simply add those two values together and you divide by 2. Now the median has a partner that goes with him. Every measure of center also has a measure of spread. Okay, what the spread is the spread tells us how spread out the data is. And you must always report a measure of spread when you're reporting a measure of center. So, spread answers the question, are the values of the distribution tightly clustered or are they more spread out? Now, the spread for the median, there's two different values that people think of. The first one they think of is the range. Now, you've probably calculated the range before. It's simply found by taking the maximum minus the minimum. Here's the problem. The range has a very big disadvantage. Remember those outliers we talked about the last lesson? If you have an outlier, which is considered a single extreme value, it can make the range very large and not really representative of the overall data as a whole. So we don't use the range for the measure of spread. We use what's called the interquartile range, or abbreviated IQR. The interquartile range is your upper quartile, which is Q3, minus your lower quartile, which is Q1. Now this one has a much bigger advantage. Because we're only using the quartiles instead of the maximum and the minimum, it lets us ignore those extreme values, whether they're low or high, and only only concentrate on that middle part of the data where a majority of it is located. So if you are calculating the median and you're reporting the median, along with the median, you must always report the interquartile range. They go together. Now, let's look some more about quartiles. The quartiles that we discuss divide the data into 4 equal sections. You think quartile, quarter, that's where you get the idea of 4 from. 1/4 of the data lies below the lower quartile, so 1/4 is below Q1. 1/4 of the data lies above the upper quartile, or Q3. And the quartiles, Q1 and Q3, they border the middle half of the data. The lower and upper quartiles are also referred to as the 25th and 75th percentiles of the data. And the IQR, which is between Q1 and Q3, contains the middle 50% of your data values. So now there's a second center that we discuss. The other measure of center that we discuss when you have symmetric data is the mean. Again, this is only appropriate when you have symmetrical data. So let's highlight that. When you have symmetric data, you calculate the mean. Now, I'm sure you've calculated the mean before. It's also known as the average of the data. You simply find it by adding all the values up and dividing by the total number of values. It's also referred to as the balancing point. But again, your graph is required to be symmetrical. Now, this lovely thing right here, this is the formal formula for mean. Some important pieces of it. this notation here, it's called X bar. It's simply the notation for mean. This guy right here, this is a Greek letter. It's the Greek letter sigma. It means sum. So add up all of the X values and then divide by, N represents simply the number of data values. So add up all of the X values and then divide by the total number of data values there are. Now, let's talk about what's more important, the mean or the median. Because the median considers only the order of the values, it's resistant to values that are extraordinarily large or small. So, if your histogram is symmetric and there are no outliers, we consider the mean to be a better choice to use. However, if the histogram is skewed or you know there are obvious outliers, your better choice is the median. So those first two sentences, just a little hint when it comes to studying for your test. These two sentences right here will be very important to know. Also, when the histogram is symmetrical, the mean and the median are roughly the same value. When the histogram is skewed, remember it has a tail, the mean is always pulled towards the tail. So a graph with a skewed left tail has the mean pulled to the left, so the mean is going to be less than the median. A graph with a skewed right tail has the mean pulled to the right, so the mean is greater than the median. Again, just a helpful hint, this is something that I would study and know for the test. You never know when those questions might pop up, that it's good to know information. Now, we talked about the mean. He was your other measure of center, but if you remember, we always, when we report the measure of center, we always have to report a measure of spread with it. So, the measure of spread that goes with the mean is what's called standard deviation. Let's talk about where this comes from. The concept of just deviation in general is the distance that a data value is from the mean. So every single individual data value has a deviation. Now, variance is found, and this is more of a formula kind of wordy business, it's found by summing the squared deviations and averaging them. The notation for variance is S squared for the sample and sigma squared for the population, although the one that we will be using the most is this one right here. So that's the notation for variance. Standard deviation, which is really what we're trying to get to here. Standard deviation is found, first of all, by square rooting your variance. Okay, so that's important. You find it by square rooting the variance. It's measured in the same units as the original data, and it's notated S for sample and sigma for population. And again, the one that we're going to be focusing on is this guy right here. The purpose of standard deviation, again, it takes into account how far each data value is from the mean. It tells you how spread out the data is. And honestly, it is a better tool and more powerful, and it's a much more powerful measure of spread than the IQR. But remember, we only use the mean when we have symmetrical data. So if we have that outlier, we have to use the median, which means we have to use the IQR. So our focus on the rest of this lesson is how to calculate standard deviation, because calculating IQR is very easy. Standard deviation is not. So I'm going to start by maybe scaring you a little bit. These are the formulas to find variance and standard deviation. A little overwhelming. And I personally wouldn't want to be handed these formulas and be told, hey, let's use these. So guess what? We're going to pretend none of these formulas even exist. I'm going to break it down step by step and take you through the process of calculating standard deviation. So let's look at some step-by-step directions. The first thing you have to do in order to calculate variance and standard deviation is to find the mean. We all know how to find that. Not a hard thing to do. Then you're going to take each of your original data values and you're going to subtract the mean from them. That's represented by x minus mean. Whoops, let's use a different color. X minus the mean. Then, whatever answer you get from step 2, you're simply going to square those values. What squaring does, by the way, it takes away the negatives. Then, once you've squared all of those numbers, then you're simply going to add them all up. Because remember that little sum guy there, that little E-looking guy, he means sum. Then, the first step you have to find is the variance. So once you've added them all up to find the variance, you divide by n minus 1. And then finally, to find the standard deviation, you simply square root the variance. So now we're going to put these steps to work with some examples. So for each of these examples, we're going to start by calculating the median and the 5-number summary and the IQR, just to practice finding those things by hand. Then we're going to have to find the mean, because we need the mean, and then we're going to calculate the standard deviation using a very easy-to-use table. So let's start with the 5-number summary and the median. So the 5-number summary and the median, uses the minimum, Q1, the median, Q3, and the maximum. Well, here's our data. 4, 7, 7, 7, 10. They're already in order from lowest to highest, which is a bonus. The first 2 easy ones to fill in, we know the minimum, the lowest value is 4, and the highest value, the maximum, is 10. So if we are finding the number in the middle, 4 and 10 would cancel, 7 and 7 would cancel, so this guy right here is your number in the middle, or your median. Now we can't use him again. To find Q1, we only use the numbers on the left. Well, there's only 2 numbers, 4 and 7. So Q1 is technically right here in between them. And Q3, well, let's do Q1 first. So to find the number in the middle, we have to add them and divide by 2. 4 plus 7 is 11, and 11 divided by 2 is 5.5. We're going to do the exact same thing to find Q3. It's right here in between these those two, sorry. We're going to add them. 7 plus 10 is 17, and 17 divided by 2 is 8.5. So that's your 5-number summary. So next on the list was the IQR. So this is the spread that goes with median. Remember, they have to go together. So the median is 7. The IQR we would find by taking Q3, which is 8.5, minus Q1, which is 5.5, and 8.5 minus 5.5 is 3. So that's all of the information if I asked you to find the median, the 5-number summary, and the IQR. Now, we're going to do the other measure of center. That would be the mean. So to find the mean, we have to add all the numbers up. Well, 4 plus 7 is 11. 11 plus 7 is 18. 18 plus 7 is 25. And 25 plus 10 is 35. Then, we have to divide that by how many data values there are. Well, there's a total of 5 data values. So our mean comes out to be 7. So that was your first step. If you're looking at your notes on the previous slide, the first step for finding standard deviation was to find the mean. Now we're going to move over to this table. It says, step number 2 says, take each original data value and subtract the mean. Well, to fill in this table, I'm going to start by writing down the data values. 4, 7, 7, 7, 10. So this next column is step number 2. Take each x value and subtract the mean, which is 7. So 4 minus 7 is negative 3. 7 minus 7 is 0. Again 0. Again 0. And 10 minus 7 is 3. Well, step 3 tells us to square each one of those values. That's what the next column is. If I take negative 3 and I square it, I get positive 9. 0 squared is 0. Again 0. Again 0. And 3 squared is 9. Step 4 now says add all of those numbers up. So we're going to add these up. Well, 9 and 9 make 18. So now we need to find step 5, which is the variance. So to find the variance, we're going to divide this by 4. 18, where did I get 4 from? I divide by n minus 1. Well, n is the number of data values, and there were 5 of them, so 5 take away 1 is 4. So 18 divided by 4 is 4.5. And then step number 6 says to find the standard deviation, SD. We're going to square root the variance. So the square root of 4.5 is 2 point, and I'm going to use 2 decimals, 1, 2. So for standard deviation, let's just stick to 2 decimal places. 2.12. So that's the main idea. It's not a hard process if you have this little table and you can go through the steps in the table. So we're going to have 2 more examples just like it. So we'll pick up the pace a little bit. A new set of data values, 100, 140, 150, 160, and 200. So again, we're going to start by finding that 5-number summary. We got the minimum, we got Q1, we got the median, we have Q3, and we have the maximum. The 2 easy ones to fill in are the lowest, 100, and the highest, 200. We have 5 data values, cross them off, and we end up with 150 in the middle. So the median's 150. So Q1 is right between those because there's only 2 data values to work with. Well, 100 plus 140 is 240, and 240 divided by 2 is 120. We also have a number over here in between these two. 160 plus 200 is 360, and 360 divided by 2 is 180. So there's your 5-number summary. And we also need the IQR because we just gave the median. So Q3, 180 minus Q1, 120, leaves us with 60. So now we have to find the mean. So pick up your calculators because this is a little tougher to add. Add up all those values. I get 750. There's still 5 data values, so divided by 5. Whoa, don't know what happened there. Let's try that again. 750 divided by 5. I end up with 150. So, but with the mean, we got to have the standard deviation. So let's go ahead and work with our table. Each of your data values, 100, 140, 150, 160, 200. We need to take each of our data values and subtract 150. 100 minus 150 is negative 50. 140 minus 150 is negative 10. 150 minus 150 is 0. 160 minus 150 is 10. And 200 minus 150 is 50. Then the next column says we square each one of those. Well, negative 50 squared should come out to be positive 2,500. Negative 10 squared is positive 100. 0 squared is 0. 10 squared is 100. And 50 squared is 2,500. All right, so now what? Well, we have to add them all up, remember? So add them all up. 2,500 plus 2,500 is 5,000, plus 100 and 100 makes 5,200. Now to find the variance, we have to divide that by n minus 1. N was 5. 5 minus 1 is 4. If we divide that by 4, I end up with 1,300. And then to find the standard deviation, we square root 1,300 and round to 2 decimals, and I get 36.06. All right, so let's look at the last example. So this time we have 6 data values, 10, 16, 18, 20, 22, and 28. So let's go through the same process. We need to find the minimum, we need to find Q1, we need to find the median, Q3, and the maximum. So the easy one is the lowest, 10, and the other one, highest, is 28. These are in order, so we're ready to cancel. If you cancel from both sides, though, your median ends up right there in the middle. Well, that's not a bad thing. The middle of 18 and 20, hopefully you know, is 19. What that makes easier, though, is finding Q1 and Q3, because that line is the dividing line. You have 3 numbers on the left. So 10 and 18 cancel, 16's in the middle. That's your Q1. On the right-hand side, there's also 3 numbers. 20 and 28 cancel, 22 is in the middle. So when there's an even amount of numbers, the median you have to find by adding and dividing by 2, but the quartiles will be easier to find. Now we have to find the IQR, and that's found by taking Q3, 22, minus Q1, 16, which comes out to be 6. We also, so there's all of your median-related stuff. We have to find the mean. Add them all up. If you use a calculator, I ended up with 114. Divided by, there's a total of 6 values. And I end up with a total of 19 for my mean. So let's take a look. Data values, 10, 16, 18. Make that look like an 8. There we go. 20, 22, and 28. So this time we have to take each one of those data values and subtract 19. 10 minus 19 is negative 9. 16 minus 19 is negative 3. 18 minus 19 is negative 1. 20 minus 19 is 1. 22 minus 19 is 3. And 28 minus 19 is 9. So again, we have to square each one of these. Negative 9 squared is positive 81. Negative 3 squared is 9. Negative 1 squared is 1. 1 squared is 1. 3 squared is 9. And 9 squared is 81. So I got to do a little movement over to the other side because I'm out of space. Next step, we have to add them all up. If you add them all up, you get 182. So I'm going to go over here. To find the variance, we have to divide that by n minus 1. So 6 take away 1 is 5. And that left me with 36.4. Then to find the standard deviation, we have to square root that answer. And the square root of 36.4 rounded to 2 decimal places is 6.03. And so that's the end of our lesson today. Today's focus was again calculating the different statistics that relate to quantitative data.